Right, hello everyone. So again, we have our video here, and for this video we are going to have or to discuss the real number system. So as you can see, I have the following sets here under the real number system. We have the rational numbers, check; integers, check; whole numbers, check; and counting or natural numbers. Now notice that on the bottom part we have the counting and natural numbers notated by the capital letter N. The example is these numbers. So it's natural counting. We start with 1, 2, 3, 4, 5, so on and so forth until infinity. Okay, so these are the examples. Now going up, we have the whole numbers, which is composed of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Same with counting numbers, it also goes on forever. The only difference is the value 0 or the number 0. So this is the difference between counting numbers and whole numbers. So if you will be asked W minus C, the difference there is actually the element 0. So if we recall the set operations that we have discussed before. Now the next one is what we call the integers. Talking about integers, these are the numbers now that will involve, let's enlarge this one, involve positive and negative. And actually when you were in grade 6, you discuss this one thoroughly and you were introduced to this one as well. So here we are also going to look back, especially operations governing integers and other signed numbers. Now take note that 0 is neither positive nor negative. So to the right of 0 you have the positive numbers, and to the left you have the negative numbers. As you go farther to the right, your value gets bigger and bigger. When you go farther to the left, the value goes smaller and smaller. Okay, so those are what we call our integers. So let's put it right here, and we represent integers with the capital letter Z. We actually two kinds of Z's. You have Z plus for the positive ones and Z minus or Z negative. And you also have rational numbers. Rational numbers are all the rest of the numbers, from counting numbers, whole numbers, integers, with addition of fractions, decimals, percentages. So fractions and decimals can mean the same thing, or they can be, it's just a form of writing actually. But in terms of decimals, we have a rule when we talk about rational numbers, or we have something that we need to qualify, or conditions. The first condition is rational numbers in terms of decimals are decimals that are terminating. Okay, what's the meaning of terminating? It means it ends. Terminating, and I would like to highlight this, or number 2, repeating. So when you talk about terminating decimals, it ends. Like in this example, you have 0.25. It's a terminating decimal. An example of repeating decimal could be 0.33 with a vinculum, because it means it goes on forever. That's repeating decimal. So if we're going to summarize rational, integers, whole numbers, counting numbers, we actually have this what we call Venn diagram. And just to enlarge that, all right, you can see here that the smallest circle is natural number, which is inside the whole number. Whole numbers and natural numbers are inside integer numbers, and all three of them are inside the set of rational numbers. It's actually a good way to visualize where integer, whole numbers, and natural numbers would stand in terms of the set of rational numbers. And now moving on to the last, we go to irrational numbers, which is q prime. And you will notice that rational numbers is q, which means that rational numbers union q, rational numbers union irrational numbers is equal to your real number system. Q prime is equal to your universal set, which is the real number system. And what are these irrational numbers? These are the examples. These are weird looking numbers, right? So E is actually Euler's number. It's a constant, but it is primarily a number in decimal that does not terminate, meaning it's non-terminating. It's non-terminating. And I'd like to highlight this one. And, all right, it's and, non-repeating. So it does not terminate, nor it repeats. So non-repeating. So pi is a number that goes on forever. The values after the decimal point doesn't or don't end, but it also don't repeat. Okay. Square root of 2 is also the same value. Square root of 2, it's an irrational number because it's a decimal that does not terminate and does not repeat. And same is true with the rest of the value, like ln2, pi to the n, square root of 3. All right. So I hope that through this very short video, you already can recall the different sets of numbers that you've been studying since early as grade 3, grade 4, grade 5, and grade 6. Because all of these sets we need to master by now, so that when we go to higher mathematics, especially that we're knocking on the doors of algebra, we are already very much equipped with the knowledge and skills on numbers. Now, another way that we can visualize the real number system is through what we call a number line. This is a number line, a line that is composed of numbers. Here you can see the numbers that are, whole numbers and integers, negative, positive, and also 0 as coordinates. But actually, they can very much represent the real number system. As you can see, there are numbers in between. So like if I ask you what's the number halfway between 0 and 1, you will say, of course, 0.5. So in decimal, it's 0.5, or in fraction, you can say it's 1/2. And this is an example of also of irrational number. Okay, you can say square root of 2 is basically square root of 2 is around 1.4142 or ellipsis, which means that it's an irrational number. But I can approximate square root of 2 here in my number line. So if it's 1.41, I can approximate here. If this is halfway, which is 1.5, 1.41 might be somewhere here for square root of 2. So I can say this coordinate here is square root of 2. All right, and so goes for the other numbers in the number line. Okay, so that's it for now. We're going to have a study group on this one, and if you can't understand something, there's need for you to clarify anything, feel free when we are inside the classroom. So once again, thank you for listening. Goodbye.